Hello everyone. In this experiment of signals and system, we will generate a unit impulse function. Okay. So first write down in comment line, generate unit impulse function. Now before writing any of the experiment or any of the program in MATLAB, we should always have a practice of writing CLC, clear all and close all. So basically a CLC command will clear the command window. Clear all command will clear any of the variable which is open in this particular experiment, or close all will close any of the experiment which is being running behind the MATLAB. Okay, running in the MATLAB. So these are the three commands which is always very much necessary while writing a MATLAB code. Now as we are going to generate a unit impulse function, let us first understand the theory behind the unit impulse function. As you can see here, a unit impulse function or unit impulse signal, which is also called as unit sample function, is always denoted as del of n. Del of n is always equal to 1 for n equal to 0 and is always equal to 0 for n not equal to 0, or you can say otherwise. So you can see this is my x-axis, which is my time axis, and this is my y-axis, which is my amplitude axis. So the time axis is represented with n, the integer value, negative integer and positive integer. So this is 0, 1, 2, 3, 4, 5 and so on. This is -1, -2, -3, -4, -5 and so on. As you can see, we have an amplitude of length 1 at n equal to 0, and we have 0 amplitude at all other values, all other times. Okay, so this is my unit impulse function, or you can say unit sample function. So we need to generate this particular signal with the help of MATLAB code or MATLAB program. So this is our experiment today. Okay, let us proceed. So for writing a program, we need to first generate a time sequence. I have generated a time sequence of length capital N, which is 10. Next is the time is from -n to n. So this will generate a time from -n to n, or you can say from -10 to 10. So by default it will always take an increment value of 1, but for the understanding purpose I am writing here the increment value is 1. That means -10, -9, -8 and so on. So this is my declaration part, and which is over. Next, coming to the amplitude part, which we are going to plot, let it is capital Y is equal to, in the square bracket write down zeros 1 comma capital N. Now it will generate a stream, or it will generate a row vector of length capital N, comma 1. After assigning 0 value at n length, it will assign 1 after that. Then again zeros 1 comma n. So this 0 command will assign 0 for the next n number of values, n number of time. Okay. Now we need to plot this particular amplitude with respect to the time. So simply write down STEN capital Y comma n. Sorry, capital N comma Y. First you have to write down the time, then you have to write down the amplitude. Now this particular signal has a X label, Y label and title. That means we need to define the X axis, we need to write down what is Y axis, and we need to write down the title. So this part is for amplitude and plotting. So I am commenting this part. After that I'll write X label, which is my time in n, then Y label, which is my amplitude in capital Y, Then title. The title of the program is generating unit impulse signal. So this is the title of the program. So this is all about this particular program. We have finished writing the program. Let us save the program and let us run the program. So as you can see, this is unit impulse function which has an amplitude equal to 1. As you can see, the amplitude equal to 1 at n equal to 0 and has amplitude equal to 0 for all other time, -10, -8, 6, -4, -2 and all other time the amplitude is equal to 0. And as you can see, we have taken capital N equal to 10, so this is a length of 10. The length is 0 to 10 and we started from -n to +n. So with the increment value of 1, we have generated the time. Now we have already assigned the length. Let us write a program in some different way. Input length of the sequence is equal to okay. Now we have done some minor change. Capital N equal to input length of the sequence is equal to. Now the moment I'll run this program, save and run this program, in the command window it will ask for the length of the sequence to enter by the user. Okay, so let us do this. Save this code, run this code. Now length of the sequence. Now you can choose any of the length as per your choice. Previously we have taken a length of 10. This time let us take a length of 20. Now you can see the time is from -20 to 20 and at 0 I have an amplitude of length 1. So in this way we can write down the program, we can perform the experiment of unit impulse function. In the next lecture we will see how to generate a unit ramp signal, the second basic elementary signal which is used in signals and system. Thank you.